For our next example, we will be solving the trig equation 2 sec squared x minus tan x minus 3 equals 0 on the interval from 0 degrees to 360 degrees. For the first time, we are meeting one of the reciprocal trig functions, in this case sec x. Sec x is equal to 1 over cosine x. The question that arises, is there a relationship between sec x and tan x? And the answer is yes. If you recall the trig identity sec squared x is equal to 1 plus tan squared x, then it should be easy to see that if we make that substitution, we will be able to obtain a quadratic equation in terms of tan x. Replacing sec squared x with 1 plus tan squared x, we now have a trig equation with only one trig function, which is tan. When we distribute the left hand side, we get 2 plus 2 tan squared x minus tan x minus 3 equals 0. Putting it in the form of a quadratic, 2 tan squared x minus tan x plus 2 minus 3 gives us minus 1, and that is equal to 0. This can be factorized as follows. 2 tan x by tan x will give us 2 tan squared x. To get this minus 1, we multiply a positive 1 by a negative 1. The positive 1 goes in the first bracket, minus 1 in the second bracket. When we expand these two brackets, we will obtain 2 tan squared x minus tan x minus 1. I will leave it for you to do as an exercise, and you can verify that this is true. 2 tan x plus 1 is equal to 0, or tan x minus 1 is equal to 0. Taking the first factor, 2 tan x plus 1 equals 0 implies that 2 tan x is equal to minus 1, which means that tan x is equal to minus 1 over 2. Great, so our associated acute angle or reference angle alpha is equal to tan inverse of a half. Remember, we take the absolute value, and tan inverse of a half is 26.6 degrees. Now tan x is equal to negative a half. Where is tan negative? Tan is negative, you will recall, in the second and fourth quadrants. It's positive in the first and third, it's negative in the second and fourth. So we will place our reference angle always with respect to the horizontal axis. We will place alpha in the second and fourth quadrants, and we're going to pick up those two angles now. So this is the angle in the second quadrant, and that is equal to 180 minus alpha. So x is equal to 180 minus 26.6 in the second quadrant, and in the fourth quadrant it is going to be this angle here, almost all the way around. We made almost a full revolution. In the fourth quadrant, x is equal to 360 degrees minus alpha, so that will be 360 minus 26.6 degrees. So our two solutions for 2 tan x plus 1 equals 0 are 153.4 degrees and 333.4 degrees. Now our second factor, tan x minus 1 is equal to 0, implies that tan x is equal to 1, and therefore alpha, our reference angle, is equal to tan inverse of 1, and that is 45 degrees. So again, we can draw our quadrants, and as you can see, tan is positive in the first and third quadrants. So we place our 45 degree angle in the first and in the third quadrant, and we're now going to pick up x. X is equal to, in the first quadrant, x is equal to alpha, which is 45 degrees, and in the third quadrant, x is equal to 180 degrees plus alpha, which is 180 degrees plus 45 degrees. So x is equal to 45 degrees or 225 degrees. Those are the two solutions for tan x minus 1 equals 0. So our final solution, where we group all the solutions together and put them in ascending order, x is equal to 45 degrees, 153.4 degrees, 225 degrees, and 333.4 degrees.